Hello and welcome back to Triplicate, home of interesting electronics. And today we're going to move on with the Arduino based alarm clock. After spending quite a lot of time sorting out the decimal point, I've decided to move on a bit and get some of the simple stuff in place. Namely the input from the buttons and the output to the LEDs. So, the buttons. Quickly, I've defined a button structure which has a pin, an Arduino pin number, an off action, an on action, and a state. And I've defined 3 of these because we have 3 buttons. And in the setup for each of them, I defined the pin, the off action and the on action. I just assign those. And every tick for each button we call button update, which takes the state. The state consists of the last 8 states of the button. So every time it's called, I shift it left once and set the least significant bit if the button's pressed. So the least significant bit is the most recent state. And if this state value is 1, the button is just pressed, has just been pressed. So we return the on action, and if the state is 80, then the last 7 states have been not pressed, so we can assume the button's been released. So we return the off action, and if neither of these states is the case, we return action none. This gives the buttons just a little bit of debounce. So if we go back into the alarm clock.ino, the main file, so after the action from the clock update, we have 3 actions from 3 button updates, 1 for each button. And these are passed to the mode action handler in turn. And the mode action handler, I've just put some test code in here just to test the buttons and the LEDs are working. So there is the on action and the off action for button 0, the on action and the off action for button 1, and the on action and the off action for button 2. Each of these just lights, turns on and turns off one of the LEDs. So if button 0 is pressed, LED 0 is turned on. If button 0 is released, is off, LED 0 is turned off. And the LEDs are controlled by the LED set function. So far I've just written on and off. There will be flashing modes as well, but we'll come to them. And if you call LED set, it sets that LED to that mode until you call LED set to do something different. Going quickly into LED set, again, I've declared a function, a structure for the LEDs. Currently it only records what pin is used, but it will be expanded in the future to control the flashing and so forth. So there are 4 LEDs declared there, and the LED set function just takes the state, and if it's off it sets the appropriate pin high, and if it's on it sets the appropriate pin low. And this all works and didn't take a lot of debugging because it's all fairly simple. So if I press that button, button 1 LED 1 turns on, button 2 LED 2 turns on and off, button 3 LED 3 turns on and off. Okay, it's a couple of days later and I've been busy writing some software. I'm going to quickly run through it with you, try and be a bit quicker because I realised that watching somebody describe bits of software is not the most exciting viewing ever, and then we'll see if we can get on to getting it working. If we look in the mode action handler, okay, we had mode clock before, but now if both of buttons 1 and 2 are pressed, it turns on the alarm, the mode goes to alarm on, and it turns on the LED, and here we are, mode alarm on. If the alarm is on, the 1.5 second flash to the decimal point as usual, but if the clock returns action clock alarm on, the alarm has just turned on and should start to sound. So far we're just flashing the LED and setting the mode to mode alarm sound. Again, if the buttons are both pressed, it turns the alarm off and goes straight back to normal clock mode. And finally, here we are in the alarm sounding mode, where it's actually going beep beep beep. Again, it's still controlling the display from the clock 1.5 second, and it's looking for the clock producing an alarm off action. So this would normally be after an hour, it would automatically turn the alarm off, and at which point it turns the mode back to alarm on. So the alarm is still on and it'll sound again the next day. Okay, let's just quickly have a look in the clock. So in the clock update, if the millisecond is 0, it will compare the clock time with the alarm time, and if that's true it returns alarm on, and if the clock time is the same as the alarm off, then it returns the alarm off. And for now I've just defined the clock time, which is the time it starts at, and the time on is 5 minutes later and the time off is 5 minutes after that, just for testing. And I haven't as yet done anything with the buzzer, so it'll just make the LED flash slowly when the alarm's on. So shall we see if it works? Okay, so I've compiled this code and checked it compiles alright, because you don't want to watch me correcting my typos. So shall we plug the Arduino in? There we go. Now that's running the code as was, so we shall now come on. Okay, that's running. Should we see if we... right, I shall put my fingers where they're not blocking your view. And press that button and that button, and it's registered the alarm as turned on. And now we wait 5 minutes. Okay, so will it turn on and start flashing? The LED should start flashing. It does. Okay, it turns the alarm on. Okay, we'll wait another 5 minutes and see if it turns it off again. Okay, so turner's back on. When it hits 11:15, it should stop flashing and come on full. The alarm LED, that is. So will it do it? And it's done it. Great. So now if I press that and that, no, wrong two, and that, it turns the alarm off. So good. Well, I shall now turn you off and I shall go and see if I can get the buzzer code written and maybe do 1 or 2 more tests. Though it is a bit of a slow job, so you don't want to watch it. So okay, I'll be back in a minute. Okay, so here we are, the buzzer. The buzzer. So this is simply controlled by a buzzer set function, which controls the buzzer mode, which is what the buzzer's doing currently. And the buzzer mode is currently either buzzer mode off or buzzer mode flash slow, I think. Check that. Or buzzer mode alarm, should I say, i.e. the alarm is sounding. Okay, so when we turn it off, we call no tone on the buzzer pin and set the pin high so there's not a constant DC current going through the buzzer. And the buzzer update is called once every clock tick and uses the system count. So when the system count is, we need to check these numbers again. Alright, last night's code, can't remember how it works. Okay, so the mask is 7F. No, buzzer, come on, get a grip. The mask is 7F and the on value is 40 and the off value is 00. So as it goes round, it just turns the buzzer on and off, and the buzzer frequency is 400. So should we see what it's doing? I also set the alarm on time to 11:07 and the alarm off time to 11:09, so we don't have to wait quite so long for things to happen. Okay, so this should compile, because I tried to compile it last night, so let's see if it runs. That looks good. That's running. So if we turn it on and wait for 11:07. Okay, that is not doing what we want it to do. So I am going to have a play with the buzzer and see if I can get it to do what we want it to do, and then I think I will bring you back and let you know the results of my investigations. Okay, so I've bodged the code so it comes on with the buzzer mode in buzzer mode alarm, and pressing one of the switches turns the buzzer off. I've also pulled the little sticker off the top of the alarm, which does make it sound better. So shall we see what that does? Okay, there's our faulty buzzer, and pressing that turns it off. So if we look at our code, the difference is between the beeps on alarm, it just calls no tone to turn the tone off, whereas if you actually turn the buzzer off by using buzzer mode off, by calling the mode buzzer mode off, here I actually call a digital write and set the buzzer pin high, force the buzzer pin high, and that worked. When the buzzer, between the buzzer beeps, there was that nasty high pitched noise, and when I actually turned the buzzer off using the switch, it was good. So as you can see, I've already tried this and commented it out again to show you. If I put that back in here and we try this, we get what we want. And if we press that, oh, it turns off, thankfully. So I'm now going to put the code back as it was, hopefully. And I am going to, where's the include GodH, double the frequency, a bit of a higher noise, and shall we see if that works? Okay, I've got to turn the alarm on. Okay, well it comes on. Don't think that is twice the frequency. So anyway, it'll do. It works for what we want here. I'm just gonna reload the code to stop it beeping. So now I think we will go in and work on being able to turn the alarm off from the buttons and the snooze facility. Okay, I've decided to wrap this one up here. Just did make a couple of changes. These buzzers are terrible things, and you have to put the right frequency in to get a nice tone out, otherwise you get a horrible grinding noise. So I actually put 2000 Hertz in the end, and I speeded up the beep, double the speed of the beep, so it sounds a bit more insistent, a bit more like an alarm. So let's give that a try. So we'll turn the alarm on, and I'll sit here and wait. and you will get to cut out the waiting. And there we go. So next time we'll get into being able to turn the alarm off from the buttons and the snooze feature. So from now it's goodbye from Triplicate, home of interesting electronics. Goodbye. And that's a noise that makes me glad I retired.